Brilliant. All right. So, welcome to today's talk. We're here with Andrew Norman from Encora Energy, who will be talking us through his recent article for iPowerE on using artificial intelligence to diagnose systems, not just equipment. Andy, would you like to introduce yourself and tell us a bit about Encora, please?
Yeah, thanks, Ed. So I'm a mechanical engineer by background. I started off originally in oil refinery. I worked for BP, and I did some consulting. I got to travel all around the world with a company called KBC, doing consulting on reliability and maintenance and stuff for process industries. I now work for Encora Energy, and we're in power generation. We primarily do kind of small scale power generation plants, and we're involved in a lot of the changes that are happening with the energy market at the moment. But the other thing that we're doing, which is really one of my primary focuses, is working with a company that we know, UpTimeAi, who are a startup company based in the States, and they've got a big technical center in India. That do artificial intelligence for monitoring of process plants. And by process plants, I mean, oil refineries, petrochemicals, chemicals plants, power generation, pharmaceuticals, even breweries. You could apply this stuff to. And that's really my focus within Encora. That's the main thing that I'm interested in, because we found that this is a really great and interesting product that we think has got real benefits for the UK and Europe. But as they're a startup, although they've got a lot, they're growing massively in the States and in India. They didn't have anyone to represent them in Europe, so that's what I'm doing.
Brilliant. So I think for those who are watching who maybe don't know so much about what AI actually is, if you could kind of briefly explain that for us.
Well, artificial intelligence. Well, I mean, how do you sum up artificial intelligence? I mean, artificial intelligence is everywhere at the moment. You'll know that some of the general applications are things like your smart speakers. It's what feeds stuff on Facebook and on Netflix. All of the stuff that you see is all done through artificial intelligence. And there are different levels of artificial intelligence. And I don't think I've really got time to kind of go into the detail right now, but I'm sure there are ways that I could. There are other things that I could show you. There are other videos and things that I could show you that will talk to you about the differences between machine learning, deep learning, specific and general artificial intelligence. And all that things is really interesting, and I would absolutely recommend that you go out and research further about those things if you're not already aware of them. Because artificial intelligence is everywhere, and it's doing a lot of things, and people are constantly trying to apply this to everything at the moment. It's a really big growing field. And sometimes it works and sometimes it doesn't work quite so well. And it's really worthwhile trying to understand what the difference is and how these different systems work. But as a kind of a high level, really what it does is it takes in data, generally quite a lot of data, and basically will order it and sort it and be able to provide some understanding in really quite incredible ways that you can analyze data in ways that are just incredible and would never be possible through humans.
Brilliant. So bringing the focus towards your iPowerE article recently, would you like to just give us a quick overview and then maybe just go into details on the figures as well as kind of the case studies you've got as well? We'll put a link into the description when we post, and this will be up online, so people can have a good read of it as well. But it might be just great for those watching to be able to just run through the article, please.
Yeah, I'll try and give you a kind of general overview.
Yeah, great. Thank you.
So this is really about the application of artificial intelligence to monitoring of process plants. And the question we have to ask really is why do we want to do that? And the reasons are really because you want to be able to tell when your oil refinery or your chemicals plant, your power plant, when that's changing in a way that could indicate that maybe it's not as efficient as it could be, there's something's going to break, and you really need to kind of have a good sense of that, because there's some big money in that stuff. If you break your oil refinery, I've been working a lot with oil refineries in my history. And if you have a problem on an oil refinery, you have to shut down, that's $1 million a day, right? So there's big money in making sure these things, you can predict them ahead of time, and you can really understand, what's going on with your plant. So the technology for actually monitoring of your plant, that all started around about kind of in the 50s and 60s, and it started off really basic. It was basically, you get a sensor, something that's talking to you about your temperature or your pressure or your level, or one of those kinds of bits of information that's coming off your plant, and you'd have a threshold on it. So if it went above or below a particular threshold point, it would alarm, and your engineers and operators would all rush out onto the plant and try and figure out what's going on. And that's very basic, and it gave some sense of what's going on. But I mean, these things are fluctuating all the time. All of those parameters are just going up and down in really quite complicated ways. And if you have that very simple threshold for your alarms, then where do you set the threshold? If you set it too low or too close to the normal point, then that alarm will just keep triggering, right? Because the general fluctuations of your plant will continually go up, above and below that threshold.
Right.
And of course, if you've got an alarm that's continually, going off, what happens? Nothing. Everyone ignores it. Nobody's interested in an alarm that keeps going on. So that's no use. So what happens if you put it too far away? Well, then it's just not going to detect the problems. So was always a skill to being how, where do you set that, and how do you analyze those things. So then around about the 80s, they started to get much more developed than that. They started to use fundamental machine learning, which is where artificial intelligence in a basic form starts to come through. And you use things like advanced pattern recognition, APR. And it would basically, what you could start to do then is you start to look at
sorry, and you just introduced APR there. Do you mind just being maybe elaborating what that is?
Advanced pattern recognition. So essentially,
Brilliant.
What you're trying to do then is, rather than just have a simple, above or below the threshold, what you can do is you can create a model of your piece of equipment, and how each of the different parameters should change with each other. So say if you've got a pressure, if that pressure goes up, then probably the temperature is going to go up as well. Or if you've got a flow, that's going to be related to those other parameters. And you can model that based upon what you know about that, about that turbine and that piece of equipment. And that will allow you to be able to just get a lot more advanced in how you're looking at that piece of equipment. You can now start to, rather than just have this fixed threshold where it will alarm, you're allowed to be able to take in all of those other considerations into account. And that's been really good. It's actually done a lot. These systems are now, very, very mature. They're really good. They're providing lots of great benefit to plants in lots of different applications. But still, the problem with that is you can only really start to look at maybe one piece of, just the piece of equipment itself, and it's the big pieces of equipment. So, it's the really big, the most important piece of equipment that you've got are the only things that you can really look at, because of the time and the effort it takes in order to develop that model and to change that model when anything changes. So you do some maintenance, you've got to change all of that. Something changes on your plant, all of that's got to change. So just the time and the effort to do that limits you to to what you can actually do with those models and what you can develop. And it also means that you can only really look at just small areas of the plant, and anything that's happening that's upstream, downstream, anything that feeds into or goes on from that piece of equipment. So with the example of a power plant, if you've got a steam turbine, then upstream of that and the steam will flow downstream to the turbine. If you change something in the boiler, well, that will not necessarily impact the turbine. And if you have any changes there, well, then if you've only modeled the turbine, you can't take into consideration all those things that are upstream or anything that's then downstream of it.
Right.
And you can't take into consideration anything that you might consider as auxiliary equipment. So there's a lot of other things that go on around the turbine. You've got to have coolers, you've got to have things like lube oil pumps, and they have their own coolers to make sure that you've got the right oil and it's the right temperature into the bearings so they don't burn out. Anything that changes in any of those systems, well, then you can't really consider that because you've only really considered the turbine. So the bigger that you can look at these systems, the more that you can consider everything. You can consider it all together.
Yeah.
And the bigger that you can get, the better, because it allows you to be able to understand all of it all together. And that's really where artificial intelligence comes in, because there are a number of things. Number one, you can deal with a lot more data because of the systems here. The improvements in artificial intelligence allows you to deal with a lot more data. And the other thing is, with the current generation of artificial intelligence, which is really new technology, this is the stuff that's been around for 5-10 years and has improved massively in that time. It actually allows you don't have to model the you don't actually have to model the equipment in terms of what the turbine is and all of those various systems. You just have to let the system, the artificial intelligence system, understand what normal is. So it can soak up all of that historic data, and it'll be able to just then figure out what's normal, and be able to really, from its own understanding, see what's normal, what's abnormal, and create its own understanding of what's actually going on, rather than having to use these models, which are always limited by how well you can create that model.
Yeah, because I mean, in one of your condenser figure threes there, Andy, is talking about the anomaly score over reference period. So I guess that's very much similar to what you're saying, is that it finds the points where they normally are, and that would take over the whole condenser, which is just one part of the turbine of the whole plant.
Yeah. Well, I mean, maybe let's talk through a couple of those figures. I think probably what I'll talk about first is figure 4, because that really, I can talk then a bit more about how the UpTimeAi system itself really works. So what it does is it takes in all the data from all of those different sensors that you've got all the way through your system. And it will then, from each of those, it will understand the relationships between each of them and work out what it should normally be. And then as you're operating the plant, it will go through, and for each of those different parameters, it will essentially, based upon all of the other data that it's got, work out what that parameter should be. Okay. If it's normal operation, and based on everything else, what should that parameter be? And it will do that for all of those parameters in turn. And then it will compare that to what it actually is. And that's what you can see on figure 4. So there, what you've got are 2 pressures. You've got the inlet and the outlet pressure for your, for your water box and your cooling water system as part of your condenser. And you can see the blue line, that's what the artificial intelligence is saying. If this was running how traditionally it has always done, this is what it should be. This is what I predict that should be. And then you've got the red line, which is what it actually is. And you can see that generally it tracks quite well. But then you start to get deviations. You can see where it's starting to, actually, go away from that predicted value. And that indicates that something's happening there. It indicates that either you've got an inefficiency or that there's, something's going to break, and it can indicate a number of different things. And what the artificial intelligence system does is it does each of those for each of those different sensors, and then it will essentially score how far that is deviated from what it predicted, and it will create an anomaly score. And that's what figure 3 is. Right. So if you look at figure 3, you can see that that's for the entire system. Now it's got that anomaly score, and you can see that in certain places you can see that it's hovering there between 0.05 and 0.1 to start off with, and then around about January in 2016 something starts to happen, and it notices that. It triggers an alarm. It says something's happening here, and you get that you can see that then the anomaly score starts to go haywire. That particular instance was actually a problem with the sensor, which which you can then deal with and you can correct.
Okay.
And then it carries on, keeps going, but then you see that anomaly score getting bigger and bigger, and that indicates that there's something's going on. You get another alarm, and that will kind of indicate that something's going on, and there's a problem with your system.
Yeah.
And then
how oh, sorry, but I just wanted to ask how,
sure,
when it's predicting the true value that these the actual values, how accurate are these actual values that it generates? Can you be like 100%? Yeah, is it?
Well, it depends. I guess it kind of depends what you mean by accurate. So there's a couple of things that you might consider there. First of all, you might consider, well, is the data that you're getting off the plant, is that good data? Because these sensors, as they work, right, they're just pieces of equipment like everything else. And the data that you're getting from the plant on a general sense, and that's your red line in those charts. That's data from your plant. And in any one of these systems, you should always have at the front end, and they would have at the front end, something which goes through and is data cleansing. So it will go through and it will look for anything that indicates you've got a problem with the calibration of your sensor. It will look for anything where it's broken, it's giving off a wrong signal. It will look for occasions where it's maybe maxing out, so it's gone above and beyond the range. So there'll be an initial bit there just to sort out what that data is and be able to figure out what that is. The other thing that you might consider in terms of wrong data, well, so the system is making predictions based upon its knowledge of what has happened previously, and it's talking about what it knows about the relationships between those parameters. Now, there are other systems, and the older systems, the more basic machine learning systems, what would happen is that you would get a whole load of data of how the plant works, and you would train up the system of what is normal. And then you'd run it, and it would just continue to figure out, based on that training data, what's going on and how it's operating. But it wouldn't get any better. It would just take those predictions in terms of that initial training data, and if something changes, if something's different, then actually suddenly it's like that model again. It's broken. It doesn't work. You've got to go back. You've got to find some new data and then retrain it up. And that's the more basic machine learning. When you start getting into the much more advanced specific artificial intelligence, it starts then to you've then got essentially what is a feedback loop. So there's within UpTimeAi, there's a feedback loop which basically it will, when it alarms, it'll allow the operator to say, this is something new, or this is, to be able to kind of teach it about what's going on. So whereas before you would basically have to, just retrain it on whatever's going on, with the feedback mechanism, with the workflow within UpTimeAi, it's actually able to it will give you an option then to say, well, when there's alarm, you can say, yes, this is true, this is a real alarm, there's something going on, and this is what's happening, and it will learn from that. It'll be able to take that into consideration. Or you could say, no, this is not right. This is a false positive. Actually, there wasn't a problem here, and if this happens, something similar to this happens again, actually you can ignore it, because you need to learn, and something is different there. Or you could say, no, we changed it. We've done something different. So we changed out the rotor on the turbine. So everything's now suddenly different. So the reason why you get an alarm this time is not because this is wrong. It's just that now something's different and it's changing. And that really allows the system to be able to figure out and continually learn, much in the way that like a human would. As a baby grows up, it finds new things, it asks questions, and it gets fed what the answers are, and it learns from that, and it understands what's good and what's bad, and how those things are. So we'll all continue to learn, and that's really the advantages of this absolute latest version of artificial intelligence.
We did have a question that was quite important, and I was wondering if you might be able to share your views on it. But we were thinking, does the rise of AI decrease the demand for specialist engineering roles? And what could we expect to see in the future job market for the power sector as a result of this?
Yeah, I like that question. I do like that question, because it really speaks as to what artificial intelligence is going to do, and not just in engineering, but very specifically in engineering. And that really comes down to what does artificial intelligence do, what can it do, and what can it not do. And the answer when it comes to what's an engineer's role going to be in future, the answer is going to be different, right? There are certain things which are going to be not so required, and there are certain things that are going to be just as required, if not more required. So what can artificial intelligence do? It can analyze, right? It can analyze. That's, it's just above anything that a human would ever be able to do. It can analyze data on a 24/7 basis. It never forgets anything. It will be able to use not just the data that's on your plant, but anything similar anywhere around the world. And it will be able to do all of those kinds of things that will allow you to analyze that data and provide you understanding in a really specific context. And we're talking here really only about specific artificial intelligence, because at the moment there is no such thing as general artificial intelligence. People are working on it. Whether it's ever possible, who knows? But really, this is very specific artificial intelligence. So what can't it do? It can tell you what's going on with your plant. It can point out things, and it can talk about what's happening with your specific plant at that point. But it can't tell you the broader context. It can't give you any understanding of the broader context. So it can say, yes, you've got a problem with your plant, but what does that mean for your economics? What does that mean for your high-level maintenance strategy? Should you be maintaining this right now? Is there something that you should be doing straight away? Or are you making lots of money right now, and actually you should plan this out and maintain it in a year's time? It can give you a lot of information that will allow you to make those decisions, but it can't make those decisions for you. And it also can't, creatively problem solve. It can't, should you redesign it? Well, it won't be able to tell you that, right? That's still an important skill that an engineer needs. It's one of your fundamental engineering skills, and that will become just as important, if not more important. And I guess the final thing that it really can't do is it can't influence and lead, right? As an engineer, you need to be able to influence people what the right solution is, and be able to figure out, how do you get people to back this idea? World events over the last 5 or 10 years has demonstrated that you can do a whole load of analysis, and people do lots of analysis on lots of different sides, but the ability to influence people and show you, get people to go along with your idea is a fundamental skill. And that could be just from, how do you convince another engineer that you're working with that yours is the best plan, right the way up to how do we convince the entire planet how we should be dealing with our energy and how we should be generating and using energy in the future, right? These are all important skills. So in terms of what is required of an engineer in the future, those basic analytical skills, the ability to kind of, I guess, just look at a piece of equipment and look at the data and go, oh yeah, I think this is what's happening. Those are going to become less. That's kind of, it's all going to essentially be taken over by artificial intelligence, and that's probably not a bad thing for young engineers, because I mean, I found in my my experience that there's been an awful lot of importance on engineers who are now in their 50s, 60s, even 70s, that have vast amounts of experience, that have seen lots of different things and are really in demand to be able to diagnose stuff. And they're all starting to retire. and we're starting to lose that knowledge, and they've been very important, and we won't be able to have that anymore. So it's good that now we have this technology that's coming through. That means as a young engineer, you don't necessarily need to have all of that experience and that knowledge, because your artificial intelligence will provide that. But what you do need to be able to do, and these are the skills that you really do need to work on, is looking at this in a broad context, understand what this thing means in terms of everyone else you're working with, and what everyone else cares about. Right? What does your manager care about? What's the owner of the business? What does the industry? What does the government? What does health and safety? All of those things. What are the important things that really matter from the things that your artificial intelligence is understanding? And how can you solve those problems in interesting, creative, wonderful ways? And how do you get people to actually go along with it and put those great ideas into practice? Those are the skills, the fundamental engineering skills that you really need. And fortunately, we've got great people coming up that are able to fill those gaps.
So you can have AIs to analyze, but you can't have them to lead and cooperate and create. Exactly.
Yeah.
Not like iRobot, where you got all these creative people. I guess it is quite reflective in courses at the moment, because obviously a lot of the focus is on software side, and I believe quite a lot of mention is about this full automation side of things. So we have machine learning that analyzes data, and then people are quite worried that there'll also be automation and AI will work hand in hand, so that even acting on sort of errors that AI will be able to analyze, that job market regarding like being able to fix things would be gone anyway, because it would just be done by automated systems. So from a student's point of view, it is quite a recurring subject of this AI working in automation hand in hand, and that when we're learning, it tends to be a lot of the theory we might not be able to put into practice on hands, but we might be having to implement in a software that would then automate data from AI. So it's really good to get this kind of background, because it's really what we're kind of preparing for and going to be expecting in the next couple of years. So
it's really important, really interesting, because stuff's going to change. The world is going to change. I mean, it already has been, right? I'm older than you guys. You might not realize that, but I've seen stuff that's changed over the last 20 years that the world is totally unrecognizable, and it's going to make a huge difference to everyone. Absolutely everyone on the planet is going to be having to work out what do these things mean. And I mean, I can give you high level views on stuff, but the answer is there's new stuff to experience, and new stuff that's going to come along that that we would never even be able to in a million years to just predict or consider might happen. And it's going to be interesting, and it's going to be difficult, and there are lots of challenges, and that's the job. That's what the work is going to be in the future.
Yeah, I think one of the student questions we had as well was the environmental fluctuations from things like green hydrogen, carbon capture, and electric battery powers. And I know you mentioned you can't predict the effect that it will have on the world, but also its effect on AI, really. So yeah, it'd be quite an exciting future we've got coming up.
Yeah, absolutely. I mean, and energy and process industries are, I love working in energy at the moment, just because there's so many different, so many challenges, and there's not a clear path, right? I've seen, there's lots of people who are putting forward lots of predictions and lots of almost propaganda for certain technologies. People are talking in amazing ways about hydrogen, about battery storage, and all of these new technologies that are coming through. And the answer is that at the moment there's no silver bullet. If there was a silver bullet, we kind of all know what to do, and we've got to just figure our way out bit by bit. Just work out how do we move on from anything that is causing carbon footprint, whether that's using fossil fuels in a better way with carbon capture, so that we can transition from in that way, whether it's hydrogen, whether it's just straight out electrical generation from renewables. There's no really obvious way. It's just going to slowly evolve over the next 10, 20, 30 years. And we've all got to try and do our bit and understand what the goal is, and just keep plugging away at it, because it's it's the survival of the planet is at stake with all of this stuff. So
I think I have a question. I mean, what do you think is kind of in the near future in the development of AI? What can you see? Where can you see it going, especially with UpTimeAi? What kind of things is kind of going on next?
So I think the fundamentals of AI are now kind of in place in terms of the ideas, but it's about applying them to specific problems. And we've got quite good at some of the more specific, the simpler ways in which artificial intelligence can be applied. They're starting to get knocked off, and we're getting some really good understanding there. But some more of the complicated things, you not only need the artificial intelligence, you really need to understand what actually you're applying it to. And this comes from the UpTimeAi and plant monitoring, process plant monitoring. There was an idea maybe 10, 15 years ago, a general view that if you just analyze the data, right, you didn't need to know anything about the subject, just analyze the data in the right way and it will tell you what the answers are. And unfortunately, that's just not true. We've discovered through a number of high profile problems that it just doesn't work like that. You really kind of have to understand the subject matter in some way. Just the way that the UpTimeAi deals with that. So I've talked through all the anomalies and the alarms and stuff, but actually at the back end, what it's got is what it's called the inferencing engine. So it goes through and it gets all of that data, and it sorts out all of the anomalies, and it scans against this huge database of failure mechanisms. So the back end, it will actually then be able to say, this is what we think the failure mechanism is. These are some recommendations of how to solve it. And that's the way in which you can actually start to get this really complicated problem and get it in a way that's actually usable. It's not just analysis of the data. And that's really the important thing. And that requires real knowledge of the subject. And so that's why the focus with artificial intelligence at the moment is all about applying them to those more complicated scenarios, using that domain knowledge, using the understandings of those systems, and being able to apply that knowledge and combine that in with the artificial intelligence, so you get a system that doesn't just say you've got a problem, something that's really just is very much focused for data scientists to be able to figure out, but actually can be used by plant engineers and end users, and it applies all of that domain knowledge to really make it a usable system. So I see over the next over the next maybe 5 to 10 years, people are going to be just applying this in new and creative ways and finding ways in which it's going to be able to make revolutions, bit by bit, problem by problem.
Do you think
I guess that would be sorry, go on, Izzy.
Just do you think that obviously the data is so important in AI and previous knowledge of data as well, so do you think the sharing of data across the world is going to be really important in engineering problems and being able to kind of freely share
the results of the AI, so in the sense that I guess that's on that dependency, how much we want to rely on AI by seeing evidence that it's working in certain industries with certain data sets.
That's another great question. Data is very important, and having control and access to that data is going to be very important. And how do we actually how do we deal with that? I mean, there is obviously big high profile understanding of what does Google do with your data, what does Facebook do with your data, and is it right that that data sits with those big companies that are multinational, and do they have quite the regulation that they should? Are we actually going down the right route? So it's a really good question from an engineering standpoint. How do you actually share some of that data together? But really, I mean, what happens with something like UpTimeAi is it will be able to learn from vast amounts of data sources. So UpTimeAI has got plants now starting to develop all over the world that will provide that data and new ways of looking at things. It will be able to really understand what's going on in a lot of different systems, and just having the ability to learn not specifically about what another plant is doing, because obviously there's data protection about knowing what other plants are doing, but being able to learn from them in a really rigorous way, so that it's not, you don't need to get the people involved. The system learns, and it will learn from all of those different data sets, and that will just, that will once again will allow us to revolutionize the way we deal with data and how we actually can, how we can improve our overall knowledge from all of those different data sources.
Cool.
So thank you everyone for listening, and I've learned so much from this talk. I hope you will do too. We will put some links in a post so you can find out more if you're really interested. And thank you for talking to us.
Thank you. It's been really good. Thanks for inviting me. I always like enjoying talking about this stuff, particularly people who are interested and find what I'm saying useful. I love this kind of stuff. AI is cool, it's sexy, and it's going to do big things. So I love talking about it. And if anyone's, I'm sure there'll be some great links that you can provide. If there's anything there that sparks people's interest and they want to know more, then either get in contact with you guys, or you can get in contact with me, and I'm always interested to talk about this stuff. So thank you.
Brilliant. Thanks so much, Andy. Take care now.
Cheers.